Okay, but we continue that if LF chain down here, where we say, but if the customer type is W, then we nest another if LF within that. If it's a wholesale customer, if it's anywhere, if the invoice is anywhere between $0 and $500, they get 40%. If the invoice total is more than 500, they get a 50%. Okay, so here, this is the trailing end, my mistake. This is the trailing end of the if LF. So if all of these conditions fail, right, they're all false for whatever reason, the person isn't retail, the person isn't wholesale. This chain, these if LFs establish exactly what the discount amount is, depending on whether they're resale or wholesale. If all of these conditions are false, they don't get any discount. The discount becomes 0%. So discount percent will be established up here if they're retail or wholesale. Otherwise, they don't get one. Okay, and then we come down here and we just calculate the discount amount, which is the total of the invoice times the discount percent. And then we calculate the new invoice total, which subtracts the discount amount from the invoice total. Okay, so what are we doing here? Well, what's new? Well, one thing that's new is we're using control statements that I wasn't going to get into until next week, but we'll do it now. What do control statements do? Well, they use Boolean conditions to determine the value of particular variables. Okay, and Boolean conditions are simply true, false. It's testing these conditions to be either true or false, and it's taking particular actions depending on the outcome. Okay, so let's take a look at these slides. Let's go back to the slides for chapter 3 and start getting into this. Notice when you're using indented control statements like this, you have to follow up the first statement with a colon. Okay, we'll get into that in a second. Okay, so let's go over here and we'll say, get into next week's. Okay, so what are control statements? Well, control statements include if, elif, else, ladders, and control statement include while statements and break statements and a few other statements that allow you to cause the control of the program to branch depending on the value of Boolean conditions that you insert. And what does that mean? Well, first of all, what is a Boolean condition? Boolean expressions or conditions will test the value of two values to determine if they are equal, they are not equal, one is greater than, one is less than, one is greater than or equal to, or one is less than or equal to. Okay, these are sometimes called Boolean expressions or conditional expressions that evaluate to true or false based on a comparison between two or more values. And they use these 6 relational operators. Okay, equal to will return true if both operands are equal. Right? So if I say 4 minus 2 equals 2, the entire Boolean expression is true. Note that when we're equating things with relational operators, we have to use 2 equal signs. Why is that? Well, the answer may be obvious. 1 equal sign is used for an assignment operator. So that's not going to work. So if you want to test whether a value on the left side of the equal to operator is the same as the value on the right side of the equal to operator, you need to use two equal signs. Okay, so two equal signs means it's testing whether the value on the left is the same as the one on the right. Okay, on the other hand, exclamation equal sign is testing whether they're not equal to. Okay, so if you enter a value, if I say 4 is not equal to 2, that will return a value of true, right? Because it's not. 4 is not equal to 2. Okay, greater than tests whether the one on the left is greater than the one on the right. Less than whether the one on the left is a lesser value than the one on the right. And greater than or equal to, again, whether the one on the right is either greater than or the same as the one on the left is greater than or the same as the one on the right. And less than or equal to whether the one on the left is less than or equal to the one on the right. Okay, so how do some of these work in practice? Well, so here we're testing whether age equals to 5. Okay, here we're testing whether first name is equal to the string uppercase JOHN. Here we're testing whether quantity is not equal to 0. So there are only two possible values that can be returned by each one of these statements. This statement is either true or false. That's all. Can't be anything else. This is true or false. That's all. Can't be anything else. You can compare a variable to a literal, but it has to match for this to be true. Okay, so now, because floating point values aren't always exact, you shouldn't use the equal to or the not equal to operators when comparing floating point values. Instead, you should use the greater than or less than operators. So these are so-called Boolean expressions. These are the relational operators that underpin Boolean expressions. You can also combine them. You can create compound Boolean expressions using these logical operators. Okay, and will return a value of true if expressions on both sides of the and are true, or will return a value of true if either the expression on the left or the expression on the right is true. Not reverses the value of a Boolean expression. We'll look at some examples, okay? So, and these have an order of precedence. It looks for not first, then it looks for and, then it looks for or. Okay. Okay, so what are we doing here? This entire expression will return a value of true only if this is true, age is greater than or equal to 65, and this is true, right? This entire expression returns a single value of true or false, and it's based on, predicated on this being true and this being true. Okay, or on the other hand, will return a value of true if either this is true or this is true. Okay, so what does that mean for in the case of and? In the case of and, when it's examining this first expression on the left-hand side of the and operator, if this is false, it can stop, because obviously the entire expression is not going to be true. They both have to be true. On the other hand, when it's evaluating or, it looks at this, and even if it's false, it still has to examine the value of this because it could be true. And here, notice we have compound. So, right. So this could be false.
Could you add multiple ands to one expression, like age greater than or equal to 65 and city of Chicago and some other variable, but can you have like 5 or 6 ands
Yes.
going?
Yes.
Okay.
And in that case, it's very easy to evaluate because they all have to be true for the entire expression to be true. If you have ands and ors, it's not so easy to manually interpret. It will evaluate the and part first and evaluate the or part next. Okay, so if I had and if I did something like this, and name equals John, it would look at this part first. Okay, and it would determine, in order for it to proceed, it would determine that this is true, and this is, I'm sorry, name equals John. If that is true, and this is true. They would both have to be true for this part to evaluate to true, for this expression to evaluate to true, right? So if this was true and this was true, only then would it, even, it could stop at that point because it doesn't matter whether city equals Greenville or not. Okay, so in the case of ors and ands, it looks at the ands first. And in this case, it would only have to, this is an expression and this is an expression, only one of them has to be true. The not is more complicated. And my suggestion, my advice is to stay away from nots because this evaluates to true if age isn't greater than or equal to 65. Or said a different way, this evaluates to false if age is greater than or equal to 65. So you may see my point here. It's confusing. You're looking at everything in reverse, so to speak. Ands and ors can be hard enough,